I was going to talk a little bit about a couple of new identities. And these identities will come in very handy because sometimes we think we can only find trig functions, or find them by hand anyway, exact values, nice values, when they're things like 30-degree angles or 45-degree angles. But there are a few other angles that we can actually find a nice exact value answer to, given some help from the sum and difference formulas. Now, I'll show you all 6 of the sum and difference formulas on the next page. Again, they should be added to your note sheet already. But realize that they can help us in a few different ways. So let's take a look at it here. The cosine at 75 degrees normally wouldn't have been a triangle that I would have thought I could work with. But knowing that 75 is the same thing as 30 plus 45, what we can do is rewrite this trig function as the cosine of 30 degrees plus 45 degrees. And in that case, the cosine of two angles added together, such as down here at the bottom, is the same thing as the cosine of the first angle. Notice where u is in our formula here. Cosine of u and sine of u. So we can say the cosine of 30 degrees, which we can definitely find. Then notice it says times the cosine of v, so the cosine of the second angle is minus the sine of the first angle times the sine of the second angle. And in that case, all 4 of those statements are things that we know. I especially know the sine at 30 degrees is 1/2. The cosine at 45 degrees is root 2 over 2. Again, don't forget that subtraction in the middle. And notice how that happened. The cosine of two angles added became cosines multiplied minus the sines multiplied. That's a very helpful thing to notice. Cosine at 45 degrees would also be root 2 over 2. And the cosine at 30 degrees, well, if you remember, the sine at 30 was 1/2. The cosine is the other relationship, so it's the root 3 over 2. Again, if you need to look that up on a unit circle, you can definitely do that. We're very familiar with those angles, though. Then I'm going to do a little arithmetic. Root 3 times root 2 would be the root 6 over 4 minus 1/2 times root 3, all both over 2. Again, also going to be root 3 because we're multiplying. 2 times 2 is 4. And finally, our answer would be root 6 minus root 3. Notice they're not like roots, so just leave them where they are, all over 4. Now, I know that's not as pretty as a nice simple 1/2 over, 1 over 2 or root 3 over 2, but that is an exact value answer. We've gotten rid of all of our trig functions. And again, it gives us a solid solution or a solid answer to that expression. Again, there are 6 different sum and difference formulas that we're going to be familiar with. We just worked with the cosine of two angles added together. There's also the cosine of two angles subtracted. And notice the only real difference between those formulas is in the middle. Both of them are cosine of the first angle times cosine of the second, sine of the first angle times sine of the second. But notice, cosine sum becomes a difference, and the cosine of a difference becomes a sum. The sine of u plus v, notice that one stays a sum, right? For the sine thing, the sine stays the same, if that helps you think of it that way. But the addition stays addition. But now notice where the sines and cosines are. The sine of the first angle times the cosine of the second angle, right, the v, plus the cosine of the first times the sine of the second. Same thing goes for the difference down here. Again, difference stays difference, right? The sine stays the same. But again, it's sine of the first, cosine of the second, cosine of the first, sine of the second. And then finally, tangent down here at the bottom gets real messy. But tangent addition stays addition on the top. Notice it's tangent of the first angle plus tangent of the second angle. And on the bottom, 1 minus both tangents multiplied. If it's a difference, the only thing that changes is that top, right, and the bottom. Those signs change very simply. So again, tangent of the first angle minus now tangent of the second angle. 1 plus the tangents multiplied. Let's go ahead and take a look at what that would do for us if we were actually evaluating for a tangent. So again, the tangent at pi over 12, not an angle we'd be familiar with, but notice they gave us a little hint here at the side. right? If we did a little common denominator action, pi over 3 minus pi over 4 is really the same thing as pi over 12, right? 4 pi over 12, if we thought of it that way, we want to sometimes just convince ourselves this is 4 pi over 12, right? That's pi over 3 minus 3 pi over 12, right? Same thing as pi over 4. So 1/3 pi minus 1/4 pi is really pi over 12. Well, in that case, let's switch out our tangent then for the tangent of pi over 3 minus pi over 4. And again, the tangent difference formula said we're going to take the tangent of the first angle, keep that difference, minus the tangent of the second angle, all divided by 1 plus, right? You can always double check that. Let's go look. Tangent difference, again, is minus on the top, plus on the bottom. Then those two tangents multiplied together. So again, the tangent of pi over 3 times the tangent at pi over 4. Well, in that case, we just need to know tangent at pi over 3 and tangent at pi over 4. So if we think to our unit circle, pi over 4 is a 45-degree angle, which means, remember, the tangent will be equal to 1. So let's go ahead and fill that in. Tangent at pi over 4 is a 1. Down here on the bottom, 1 plus. And again, tangent at pi over 4 is just 1. And then the tangent at pi over 3, on the other hand, well, again, that one's going to be a 60-degree angle. So tangent is opposite over adjacent, or basically root 3 in that statement. So we've got root 3 minus 1 over 1 plus root 3. Because we want to get rid of that root on the bottom, let's go ahead and rationalize by its conjugate partner here and multiply 1 minus root 3 in both of those. You'll have to trust me on this one because I'm a little out of room, but if you FOIL all that together, on the bottom here, you're actually going to end up with a -2. 1 times 1 is 1, root 3 times root 3 is 3, and the two middle terms will just disappear. So you end up with 1 minus 3 is -2. On the top, again, we essentially have that thing times itself, right? So root 3 times 1, let's go ahead and do it here. Root 3 times 1. Root 3 times negative root 3 would be -3. Again, we also have a -1, and we get a positive root 3. So we essentially get -4 plus 2 root 3's, which means let's go ahead and divide that -2 in there. We get a +2 minus root 3. Not as bad an answer as we thought we would get. Again, everything from this point onward was just some arithmetic. It's really just doing a little bit of foiling, doing a little bit of, rational root work, doing a little dividing. But the main idea is, can we take out those tangents of those angles, put in their good values, and then maybe simplify a little bit along the way. I hope that helps you with simplifying using the sum and difference formulas. I've got another video for you for some slightly larger or slightly different examples, so make sure you watch the second video, and have a great day.